Today we are going to discuss the concept of the plane geometry and the related problems, how we can solve such kind of problems. And we have already discussed and learned the idea of the calculation of the external angles and internal angles of a polygon. So here the question is related to the topic that the measure of a regular polygon's interior angle is 4 times bigger than the measure of external angle. How many sides does the polygon have? Here we have to utilize the concept of the sum of exterior and internal angles of polygon. So now for this we have to construct the diagram like you can see here. This is the figure and these are the partitions of angles like this, and we know that 180 into n minus 2 by n is equal to 4 times 180 by 5, and after calculating and simplification we can find out the value of n here, which is equal to 10. So this is very basic problem, and you can solve this. Now in second problem, how many sides does a convex polygon have if all its external angles are obtuse? So for this you can see here like what we have already given in the problem. The problem is asking that how many sides does a convex polygon have if all its external angles are obtuse. So here you can see, suppose if n is equal to 3, then the three angles x1 is greater than 90 degree, x2 is greater than 90 degree, and x3 is greater than 90 degree, and the sum of these three angles x1 plus x2 plus x3 is greater than 270 degree. So n is equal to 3. This is possible. But if we assume that n is equal to 4, then x1, x2, x3, x4 are the 4 angles, and if x1 is greater than 90 degree, x2 is greater than 90 degree, x3 is greater than 90 degree, and x4 is greater than 90 degree, you can see because all the angles are obtuse, so x1 plus x2 plus x3 and plus x4 is greater than 360 degrees. So n is equal to 4, and this is impossible because we have the sum of all the internal angles of this polygon must be equal to 360 degree. So n is equal to 4 is not possible. So therefore n is equal to 3. This is the answer. Now in problem 3, so that in a convex quadrilateral the bisector of two consecutive angles forms an angle whose measure is equal to half the sum of the measure of the other two angles. So here we have to think about the concept of the construction of convex and concave quadrilateral. We have already discussed the lecture upon the convex and concave quadrilateral. Here we have to show that in a convex quadrilateral the bisector of two consecutive angles forms an angle whose measure is equal to half the sum of the measures of the other two angles. So we go here like this is the example of convex quadrilateral, and we are assuming that the sides are not equal, and we put the point E and the angle AED we have formed here Now we can see here that the angle AEB is equal to angle D plus angle C by 2. So AEB the angle AEB is equal to the half of the sum of angle D and plus angle C now the measurement of angle A plus angle B plus angle C plus angle D is equal to 360 degree. So angle A plus angle B by 2 is equal to 180 degrees minus angle C plus angle D by 2, and angle AEB is equal to 180 degree minus angle A by 2 minus angle B by 2, which is equal to 180 degree minus 180 degree plus angle C plus angle D by 2 is equal to angle C plus angle D by 2, because 180 will be cancelled out.